In question C, we're doing the same as B, however, we are going now to 0 from the positive side. So the reason why it has to be from the positive side is because of the domain restriction on that quadratic inside the square root. So here I've drawn the quadratic as 5x squared plus 2x. It has roots at negative 2 over 5 and 0. And the square root must be bigger than 0. So we must be able to have that, only use the domain that is above the x-axis here. So our domain is going to be x is going to be bigger than 0, and we can use x's that are smaller than negative 2 over 5. Okay, so there's a domain restriction here, and because of that, and because it's at 0, we have to approach 0 from the positive side. So as a two-sided limit, this would not exist, but as a one-sided limit, it can exist. So we're going to approach 0 from the positive side here. So that's one part. Now, one thing we need to understand is as x goes to 0, okay, in general, smaller root powers of x will dominate. Okay, so when we take a look at values of x for x squared, x, and root x, notice that at 1 it's the same. As x gets big, the x squareds will get bigger than the root x and the x. However, as x gets small towards 0, the reverse is going to happen. So if I compare the value of x at 0.5, x squared is going to be 0.25, root x is going to be 0.707. It's bigger relative to, it's getting bigger as we go to the left. So the root powers actually give us bigger numbers. Okay, and as we go to 0.1, well, x is 0.1, x squared will be 0.01. The square root of 0.1 ends up being 0.316. So it's bigger than x or x squared. And again, we can keep going as we go to 0.01 for x. The x squared is 0.0001, but root x is 0.1. So again, the root x is bigger relative to the x or x squared. So as we go to 0, this difference gets bigger, right? The root numbers close to 0 are much bigger than the root powers, or sorry, the powers of x squared near 0. So root x near 0 is much bigger than the power of x squared near 0. So based on that, what's going to end up happening here then is, as we get close to 0, we then need to use an opposite argument that we used before. That essentially is going to be insignificant compared to the more dominant term of 2x. Okay, so we get a larger 2x, and then we end up with this 2x dominating, and we end up with that large number over the x, which is a smaller number. So again, this becomes really large compared to that 5x squared and also this x. This is relatively small. Okay, so therefore, the limit of this ends up being infinity. So this is really large compared to a relatively small, okay, for both of those terms. So that's one way to look at it. And the answer is, in fact, infinity or positive infinity. If you take a look at the graph of it, it will shoot up to positive infinity. So there is also an algebraic way that we can deal with this, okay? And the algebraic way to deal with this is we can get rid of the biggest powers here and then see what happens. So when we talk about getting rid of the biggest powers, I'm going to divide by 1 over x here, 1 over x here. That's the biggest power. The overall power is 1 over x. So it's going to look like this. The limit as x approaches 0 from the positive side, I'm going to end up with a square root here, 5x squared, and that 1 over x inside the root becomes x squared, plus 2x over x squared, Okay, and that's all inside the root. And in the denominator, this just becomes 3x over x. Okay, so then we're going to simplify this expression. This expression will simplify to this. The limit as x approaches 0 from the positive side, we end up with the square root of 5 plus 2 over x, and this is over 3. And now we can evaluate this limit. We're approaching from the positive side, so this is going to end up being 5 plus 2 over x becomes infinite as we go positive infinity, as we go from the positive side, over 3. Well, this is then equal to the infinity that we got before. Our previous one was just we're using a rationed analysis. The graph shows this is the case, and this is our algebraic manipulation to get us the same result.